Hey everybody, the purpose of this video is to answer the request for a video to explain the Monty Hall problem that we did in class with the three doors in tree diagram form. We had done it in class and a student asked to have it on video just so they had it, which is great. I think it's fantastic. The more videos that are out there that are useful, the better. So we'll break it down like we did in class, and I think we did it this way. So in Monty Hall, there's really two things that are going on that you have, well, actually you don't have control over it, but there's two things that are going on. There is where the prize is, which you don't know because it's randomly placed behind a door, and then there's the door you pick. So we're going to start the tree like that. We're going to put prize is behind door, and then we're going to have door 1 or 2 or 3, right? And then there's the door you pick. Now here's where it gets interesting. Starting from here, they're always fun to kind of start from a point. The prize is either behind door number 1 or 2 or 3. Okay, I think that makes sense. You pick a door independently of where the prize is behind. It doesn't matter where the prize is. You don't know where the prize is. Otherwise, you'd get it right every time. So if the prize is behind door number 1, you're either going to pick door number 1 or door number 2 or door number 3, and you have no idea which one's correct. If the prize is behind door number 2, same exact 3 options, and vice versa if it's behind door number 3. I'm not sure vice versa was the right phrase to use there, but you get the point. Now, the reason it makes sense to draw it out like this, you could also just have had 1, 2, 3, 1, 2, 3, and then had lines drawn. But the problem with that is all the lines start crisscrossing, and it's easier to see it blown out like this. You can also, with this situation and this tree diagram set up like this, see that there are actually 9 possibilities. The prize can be behind door number 1, and you can pick door number 1. Or the prize is behind 1 and you pick 2, or the prize is behind 1 and you pick 3, or and so forth and so on. So you can see all 9 possibilities here. Okay, now let's talk about whether you should switch or not. Let's suppose you don't switch. I mean, that was definitely one of the more popular kind of strategies at the beginning, was never switch. Whatever door you pick, stay with. Or another one was it doesn't matter if you switch or not. And I like both of those because we can test them using data and then also using theory. We did it with data in class a number of ways. We're also going to look at the theory here again. So the only way you're going to win if you stick with the door you've picked is if you pick the right door. Because if you stick with the door you picked, if you pick door number 1, the only way that door wins is if the prize was actually behind door, and I'm going to put that in green here. So this is a branch right here that indicates a win if you stay. I'm going to put that in green over here. Win if stay. Those are the green. Okay. The other 2 ways you can win if you stay are if you pick door number 2 and the prize is actually behind door number 2, or if you pick door number 3 and the prize is actually behind door number 3. So the only way you're going to win by staying is if the prize is behind the door you picked. Now, then you have to just ask, okay, how often does that happen? Well, this tree shows us it happens 3 out of the 9 times, which is where the 1/3 comes from. Basically, in order to win if you stay, that means you have to get the prize right when you pick the door, which happens 1/3 of the time. And that's where that 1/3 popped into in class. The other part of the tree we looked at in class is what's the chance you win if you switch. And here's the blue. Okay. So what if you win if you switch? Well, let's suppose the door is behind door number, or excuse me, the prize is behind door number 1. And you pick door number 2. Now let's just think about that. Why would that automatically be a win if you switched? Well, think about it. If the prize is behind door number 1 and you pick door number 2, At that point, Monty is going to open a door to show you an empty door. What's the only door he could possibly open? The only door he could possibly open is door number 3. He can't open door number 1, it's got the prize behind it. And he can't open door number 2 because you picked it. He'll never open the door you pick. The only door left is door number 3, which means he takes door number 3 off of the table, leaving 2 doors behind. Well, you picked door number 2. If you switch, you have to switch to door number 1, and door number 1 happens to be the one the prize is behind, which makes this branch a win, assuming that you switch. Same logic if the prize is behind door number 1 and you pick door number 3. This time, he can't open door number 3 because that's your door. He can't open door number 1 because that's where the prize is. He has to open door number 2. So if you switch off of your door onto the correct door. So once again, this is a win. And the same thing happens for the other 2 sets of branches as well. If you're on the wrong door and you switch, you have to switch to the correct door. Both of these here. I'll just circle them both at the same time. So the thing about it is once you make peace with the fact that you're most likely on the wrong door, switching puts you most likely on the correct door. That's the big kind of takeaway is once you realize that when you guessed in the beginning, you most likely guessed the wrong door. Him opening a door is actually a benefit to you. It actually gives you more information because it takes away one of the places the prize can't be. And then once you make peace with the fact that I probably was wrong in the beginning, then you switch with twice as much of a chance of getting the prize right. Okay, so hopefully that helped a little bit. I hope I did it the same way we did it in class. Maybe I did, maybe I didn't. But there she is, and I would say we'd see you in class, but it's week 10, so I won't. So be well, thanks for taking class, and we'll catch you around at some point. See ya.